Hi, I'm Bill Kinney, and this is video number 53 in my series on the foundations of arithmetic, algebra, and graphing. Video number 53, part 12 of a subseries that includes an emphasis on spreadsheet usage. In the last video, we looked at an example of money growth over time in an account that earns 2% interest per year. Let me start off this new video by showing you how to relabel the chart name, for example. So I'm going to go over here to the graph and I'm going to click on the chart title, and you can certainly change the name here and be descriptive. For example, this would be balance in an account paying 2% per year with an initial $1,000 deposit. You can resize this, I think. Well, it doesn't seem like it's letting me do that. You can certainly change the font size there. Maybe that'll make the whole thing smaller. There we go. And as I've shown you before, you can also label the axes over here. I could also relabel the chart over there. I think I'll label those things in this spreadsheet after I've made this video. And by the way, you'll notice that the name, I got this spreadsheet named up here, Alg Forms Functions Graphs, for Algebra Formulas Functions Graphs, because I'm using it a lot in this video series. I've also named the tabs down here of things I've done. Fahrenheit and Celsius. Back over here, there's the original one, f of x equals 2x, Fahrenheit and Celsius, inverse proportionality, a CD at 2% interest. I'm going to do a new sheet now, and we're going to continue thinking about compound interest. In this previous sheet, notice that this graph is increasing in concave up. The increasing nature of the graph is illustrated over here by the fact that the y values go up, and the concave up nature is illustrated by the fact that these y values not only go up, but they go up at a faster and faster rate. Over the first half year, it goes up by $9.95. Over the second half year, it goes up by $10.05, then $10.15. So they're going up at a faster and faster rate. Though if you look at the graph over here, if you imagined taking a microscope and zooming in on any piece of the graph, you could imagine that it might look almost straight. I want to illustrate that in a new sheet here. I'm going to have a spot for my balance, my principal, which is my initial deposit, a spot for the interest rate. I think I'll double click this to open it up. I'll go ahead and put 1,000 in here, and I'm going to put a smaller interest rate. Let's make it somewhat more indicative of the way things are here at the beginning of 2012. I think my savings account gives me like 0.1% interest, which as a decimal would be 0.001. That's 1/10 of 1%. And x is going to be the years. Well, actually, let's make it t, just to be different. T for time. And I'll put b for balance, just to be different there. So my initial balance is going to be the principal, which is in cell B1. Think about that. Would I want to use dollar signs or not? And yes, I would. Need an equal sign, though. That'll be my initial balance. Increase time by 1 each time. This, in this case, would be what I'm going to do. And here, I need the formula that I take my balance, which is in B1. And actually, I could have typed this in initially in cell C5 as well, times 1 plus the interest rate in cell B2. And by the way, I haven't shown you this, but you can also just, to get the cell reference, you can also just click on the cell, though it doesn't put dollar signs in. And notice that the cell reference came up here. But we want dollar signs there, so I'll type it. Raised to the B6 power, and I don't want dollar signs there, so I will just click on this cell to get a B6 there. All right, I earn $1 of interest at a 0.1% interest rate over 1 year. If I have a deposit of $1,000, it doesn't grow very much. It grows a tiny bit more the next year. I earn $1.10. which would be rounded to just $1. Let's go away. So we're looking 60 years into the future. I've only earned $61.80 of interest. Not very much at all. If you make a graph of this, and let's just graph part of it. Let's see what it looks like. Not going to focus on formatting here. It looks straight. It looks like it's linear. It's actually not. It is definitely increasing. It is definitely slightly, ever so slightly concave up. But because the interest rates is so low, it looks straight. Besides illustrating that fact that it looks straight, even though it's technically slightly concave up, I also want to show something else here. I'd like to show you another feature of Excel. We're just going to focus on the first 10 years here. Actually, I'm going to ignore everything else. I'll show you how to clear this out. Highlight those, go up to Edit, Clear All. I'll get rid of those, I think. Didn't I do it? Clear All. There we go. Something else I want to show you here is that you can use Excel has some built-in functions that you type in initially by using the equal sign again. And these functions have names that are words that indicate their meaning. And the function I'm going to use in here, the built-in function I'm going to use is equals average, and I use it a lot so you saw it come up. That's going to find the average, or the mean, of a bunch of numbers. What numbers do I want to find the average of? I think I'm going to find the average of these balances, thus giving me my average balance over these 10 years, over these 11 values actually. And I could type in the cell references C5 through C15 like this with a colon in between them. Or, what's more fun is I can just highlight the cells like that and notice that Excel automatically put C5 colon C15 in there for me. That's going to give me the average of those numbers. Now think about this. What's the average of those numbers going to be? There's 11 numbers there. You find an average by adding up the numbers and dividing by how many there are. Add up those numbers, divide by 11. You know, the numbers range between 1,000 and 1,010.04512. Probably the average is going to be somewhere around 1,005 perhaps. Let's see what it is. Yep, 1,005.01. For the purposes of illustrating something with a graph, I'm going to go ahead and use dollar signs to keep those cell references fixed, so here I have to actually type it. I'm going to put the average in each of these rows here, and then I'm going to show you that you can actually graph both of these sets of numbers at the same time. Now there is a way to just add it to this graph, but I think I'm going to delete that graph and do it from scratch. Just call this an average value column. Highlight all three columns. Maybe I should be more descriptive here. Balance, time, highlight all three columns, go to my scatter plot, which it already is on, click this, and there you go. There's two graphs at once, one for the balance and one for the average value. Oops. Now something, I don't know if it's showing up on your video or not, but it almost looks like that average value graph is decreasing. It shouldn't be. It looks a little strange to me looking at this, like it's decreasing a little bit. It should be horizontal because the average value stays the same. And I want you to note that even though the blue graph is not concave up, or excuse me, is concave up, it looks straight. And when you have a graph that actually is straight, the average value will be halfway between the extremes. Here the extremes are 1,000 and a little over 1,010. This value of 1,005.01503 is almost, but not exactly, halfway between the extremes. If I average this number with this number, I should get a number a tiny bit, I think it'll be a tiny bit more than 1,005.01503. Yep, ever so slightly higher. If the blue graph were truly straight, it would be exactly the same actually, but it's ever so slightly concave up, and so the actual average of these two extremes is slightly bigger than the actual value of the average value of the function. We'll do another example of this that's more extreme in the other direction in the next video.